Welcome back to the channel. I hope you're doing well. In this video, we are continuing the data structures and algorithms bootcamp. So if you're not already familiar, we are doing a complete problem solving interview preparation bootcamp. If you don't know anything about computer science, if you don't know anything about programming, and you want to clear your FANG interviews, you can just watch this playlist, follow what I'm sharing, and you'll be able to do so. And in the last video, we learned about stacks and queues. If you want to check out the complete playlist, you can check out the links in the description below. And yeah, in this video, we're going to continue that, and we're going to learn more about stacks and queues. So the way we do problems on this in this playlist is we first focus on like the fundamentals, like okay, stacks and queues, what is it, how does it work, why are we using it, implement it, and all sorts of things. And then in the next video, we do questions. So in this video, we'll do questions from that were asked from the topic of stacks and queues from like Google and all the big tech companies. And also not just focusing on the problems, but actually how did we realize that, okay, a stack is being used here or a queue is being used here. So in what scenario, let's say an interviewer gives you a question, how would you know that we have to use stacks or queues or whatever, right? So that's what we focus on in this bootcamp. You can check out hashtag DSA with Kunal on Twitter. There are lots of shout outs that people give that, how this course is changing their lives and, helping them quite a lot. And then they, it's the best thing they've ever seen. So let's get started. So we're learning in Java, but you can use any, project that you like. And these are the notes and everything I'll be writing. So I'll be sharing as you are already familiar with it. But one thing we'll be doing is I won't be using IntelliJ because, it's like you have to download it on your system or whatever. We're going to use Replit. So Replit is pretty simple. It's like you can code in your browser and you can actually, sign up using the link that I have just shared in the description below. So I'll just make, let's say, a new folder. I go to my REPLs, a new folder. I'll say DSA, create folder, data structure algorithms, and here, let's say, I will create a new REPL. I'll say Java, for example, normal Java, and title, stacks and queues questions. Create. There we have it, our Java file. You run this. Here you go. Hello world. Okay. So that's basically about it, and very simple. As you can see, you can create folders and files and stuff over here. You can write your code here, and don't have to worry about your packages and all these other things. Okay. So we're going to utilize this quite a lot. Let's get started. Before we move forward with starting with the questions, I want to focus on a little bit about thought process. In every video, I tell you, okay, if you face this scenario, use this structure or algorithm. Okay. Now, in which scenario would you get the hint to use stacks and queues? If you're dealing with ordering, okay, you're putting stuff in order, like, okay, I'm putting it, in order and I want to get it back in order, then you're going to use stacks and queues. Okay. A more simple example can be if you're given a question like let's say the question does not scream to you that, okay, stacks and queues will be used. But when you're brainstorming and you find yourself in a situation where it's like, okay, now it would be amazing if I can just store the elements till here or the answer till here, and then I will get back to this answer. So this, element till here, answer till here, in the order of sequences, and you're moving forward, high probability stacks and queues will be used. Okay, that's what happens in stack, right? You put stuff in, so first stuff goes in, second goes in, third goes in, fourth goes in, like a plate. In the weddings, you have plates, plate 1, plate 2, plate 3, plate 4. Now, if you want to take a plate out of it, what do? Do you take the topmost plate, or do you be like, okay, I know I like the yellow one, I will take in the middle? No, you take it from the top. So the person who got in first will be taken out last. The plate that got in first will be taken out last. So like, okay, I'm working on it. I've calculated my value till like, okay, these many elements. Now I will keep that value aside for a bit and I will see what the future holds. then you will see like, okay, well, the future is nice. Now I will take the previous value that I already had outside. So if you find yourself in a situation like this, holding values, working with like sequences, working with orders, high probability stack and queues will be used. If you need an element answer till now sort of questions, these are the popular questions that are using stuff like this. Okay, so an example I can give it to you. If I talk about, so this is another question. This is an implementation based question. So such questions are also asked. This question was asked in Google. This question was asked in Google. So it's saying implement queue using stacks. We all know what queue is because we did queue in the in the previous video. So here it's saying that okay, you have to implement queue data structure, but you have to use stacks for it. So we'll see how to do it. It's very easy question. Okay, here it says easy only, so no problem. There's one question that is called largest area histogram. This one. I think it's hard question, but it's actually very easy. It says hard, but it's very easy. So here you're given some, let's say, bars, okay? And it's saying that if you make a triangle if you make a rectangle or a square or whatever from this bar, what is the largest area that you can make? So one area you can make is, let's say, this line over here. Okay, so 1 and 1. You can't take the blank, okay? You can't take the blank. You have to take a complete rectangle. So complete rectangle can be this, 1 plus 1, area of 2. A complete rectangle can be this also like this, 4. Complete rectangle can be this, 6. Complete rectangle can be this line. You're seeing my arrow, right? Seeing my arrow? Complete rectangle can be this. Follow the arrow, see. Like this circle. I'll show you in detail with pen and paper and everything. So this is what? 2 plus 2 plus 2 plus 2, 8. A complete rectangle now, so on and so forth. So here it's saying what is the maximum one. Okay, I calculated this area till here, area till here, area till here, or whatever, area till here. I need some sort of a way to save this area till here as I move forward. So I know stacks will be used. I know stack will be used. High probability. Isn't that what we're doing here? So these are sort of the things you have to worry about, not worry about, but like take into consideration. Now, how will you gain the confidence in this? Like, Kunal, okay, you know stack is being used, but we are not that, we don't have that much amount of experience or whatever. Practice. Practice a lot and you will be there. It's very easy. Stack and queues is a very easy problem statement. Okay, but let's focus on this one first. So let's start with the easy question. Easy question asked in Google. So implement queue using stack. Very simple stuff. So it's saying that you have to make queue using stacks. It does not say stack, it says stacks, because you can't make queue with just one stack. Okay, so it's saying that okay, you have to use 2 stacks and you have to make a queue from it. Okay, so you have to implement push, peek, pop and empty. Push means what? Putting stuff inside the queue. Peek means what? Checking out the the first one. Pop means what? Removing the first one. Empty. Please, if you don't know about stacks and queues, watch my previous videos. Okay, it will be very wastage of time if I explain stacks and queues again in this video. So that's what we're going to do. No problem at all. That's fine. Cool. Let's go to pen and paper. Okay, now in this question, it's not like anything sequence. It's like telling you that stack is being used. Okay, it's nothing like you have to worry about, okay, how do we know what stack is being used or whatever. Such questions are also in linked list. In linked list, some questions are like you might not know linked listing is used. Some questions they say you, okay, reverse a linked list, do this thing and all sorts of things, and in place or whatever, swap the nodes or whatever. So in some questions they will directly give you like, okay, stack only, you have to do some functions. Okay, no problem. So queue is very simple. So queue is like like you're in the movie hall, movie cinema. So you are taking tickets in the cinema. So how do? Do you cut in line? No. If the line is empty, you will just go to the counter. The next person, where would the next person go? If say this is a counter, let me just increase the size of the font. It's too much. So let's say this is the counter. Okay. And in the counter, you're like, so the counter, ticket counter. and this is the queue railing or whatever. Now empty, it's empty. Okay, someone wants to take a ticket, it's empty, they will come here. Another person wants to take a ticket, they will line up over here. Then they will line up over here. Now, similarly, people will line up over here like this. Okay, who is going to get the ticket first? Who is going to be removed from the line first? The person who came first. So first person who came in will be the first person to get out. First in, first out. Last person who got in will be the last one to get out. In stack, it is a little bit different. If you talk about stack, then you put items in like this, let's say in a tray. So item got in first, item got in second, third, fourth. Now if you try to remove from this, who will get out first? The person who is at the top, the plate who is at the top. So the thing that got in last will be removed first. Last in, first out. Or the thing that got inserted first will be removed at the last. So first in, last out. So using stack, we have to make queue. Obviously, just using one stack, we cannot do it. We have to use 2 stacks as given in the question. Okay, so let's see how we can do that. Okay, so let's talk about this. So imagine you have 2 stacks. Okay, and Q says what? Q says what? Q says first in, first out. First in, first out. Okay, no problem. So the thing with this thing is just try it out. Okay, brainstorm. What can we do? So let's say we have 2 stacks. We call this the first stack. We call this the second stack. Now, let's say we are using the first stack to store our as an main data structure. And we are using the second stack over here as a helper. Okay, because Q is also stored in like an array like this. Okay, everything is stored in array only. This is just for visualization purpose. If you saw the previous video, you saw that we were storing it in array. And how we take it out, how we insert it, that is what defines whether it's a stack or a queue. So we'll be using this first one as the main one and the second one as a helper. Okay, now first in, first out. Okay, first in, first out. So how do we do that? So let's talk about addition and removal first. So if we talk about addition, because we can just do addition and removal, and that will basically help you out. So if you talk about addition, then how addition happens in queue? In queue, addition happens like if we talk about a queue, let's say you visualize it horizontally, but let's say we visualize it like this, a queue. Okay, so addition happens like this, just on top. 1, 2, 3, I just inverted this thing upside down. So this is, let's say, the counter now, and inserting it like this. Okay, so this is insertion like stack only. Again, realize that this is just for visualization purpose. Bottom line is they are on only arrays only. Okay, if I talk about stack, for example, okay, if I talk about stack as an array, okay, and I want to insert. So where will I insert first? 1, 2, 3, 4, 5. 0 index 1, 2, 3. Isn't that how we insert in stack? Okay, if we talk about queue, and let's say queue is also represented in an array, how do we insert in a queue? 1, 2, 3, 4, 5 in this order. Very simple. The difference is then in stack what happens is we remove from last. So removing will happen like this will be removed first, then 4, then 3, then 2, 1, then 1. In queue what will happen is first will be removed first, then 2, then 3, then 4, then 5. So as you can see, insertion is same, removal is different. So in order to insert in this queue data structure that we are making, forming 2 stacks, just insert normally in first. That's it. So insert, if you want to add into this queue, you can just say something like insert in first normally. No problem. Because insertion and it's basically similar stuff over here. Inserting like that. The question is, how are you removing it now? How are you removing it now? So if we talk about, let's say you've inserted 3 items, 1, 2, 3. This is actually, in reality, it's a stack, the data structure, but we have to make it like it behaves like a queue. So if I just do first dot remove, it will remove 3. We all know that. it will remove 3. But we don't want to do that because we want it to act like a queue. So we want to actually remove 1. How can we do that? Remember, you can't just remove first of 0 because it's stack. So you have to behave like a stack. And how do you remove items from stack? Stack.pop. And you want to remove 1. So what can you do? What can you do? Pause this video. Think about it. Right? It's actually very simple. You can remove items from here. 3 you remove, you put it over here. 2 you remove, put it over here. Okay? Sounds good? 1 you remove, you put it over here. And after that, just you can remove the just do stack.pop, means second.pop. That's it. How cool is that? And then you move these items back here. Let me show you how. So insertion is same. I just explained using the above example. This one, like, okay, insertion is same, no problem at all. But what defines it as a stack in queue is how you remove item from it. So if you have a stack, you have a helper stack, you have 1, 2, 3, 4, let's say. This is a stack, but you want it to behave like a queue. So when you remove from first, so when you do first dot remove, 1 should be removed. But if I do first dot remove or first dot pop, we know that 4 will be removed because that's the by default implementation of stack. So what you can do is empty the first into the second. Okay, empty it means remove 4, 4 will come here. Remove 3, 3 will come here. 2 will come here. 1 will come here. This is now empty. This is now empty. Now remove the last item from second. Sorry, the first item, like it's pop. Okay, because it's stack, right? So top one will be removed. Remove 1. Removed 1. No problem. Empty the second one into the first one again. Okay, second dot pop will be what? 2 will be removed and put it into the first one. Then 3, then 4. Is this not now behaving like a queue? It's behaving like a queue, right? What's the problem here though? It's not efficient. It is not efficient. You can see that if you want to add stuff in the queue, you can just do first dot add. You want to add stuff in this queue, first dot add. Simple, one step process. So complexity for that is constant. Okay, nothing you need to do. But when you need to remove an item from first, then all the items you have to traverse. If you have to remove the item from this queue that we are making using the stack, in order to remove one item, we have to traverse all the items. Complexity is what? O of n, where n is the size of first. If you don't know about time complexity, I've made the masterpiece video on time complexity. Make sure you check it out. This is very simple stuff. Linear, just size, 5 elements getting removed, 5 getting inserted. That's it. Linear. Okay. Or 2 into n, which is constant, is removed. So n. These will make sense if you watch the time complexity video. Very simple. So this is known as a insert efficient queue because the insertion is efficient. Okay. So you can only have one of the things that is efficient. Be that you can insert efficiently or you can remove efficiently. Okay. Do you want to talk about how to do remove efficiently? Pause this video and do it on yourself on pen and paper. Okay. So that is also another question that interviewer can ask you. Okay, fine, I get it. Remove is taking O of n or whatever. Can you make remove constant? Okay, we can try that. So if we talk about remove as a constant, okay, so pop or remove efficient, something like that. Remove efficient. Pause this video and do it yourself. Remove efficient. Remove efficient means when you're removing from the item, when you're removing from the stack, that stack behaves as a queue, it should be instantaneous. Okay, no problem. So if you're talking about this stack, this is the first one. This is the second, which is helper 1, and you have inserted some items. So if we have inserted, let's say the queue looks like this: 1 2 3 4 0 1 2 3. If the queue looks like this in the array data structure, you want to remove item from queue, we all know this 1 will be removed. And we all know that if we are storing this queue in this stack, the first stack, then the item on constant time that we want to remove will be the topmost item. And we know we want to remove first. So this should be like this or not. If this queue is represented like this, and I just do first dot pop, it means what? Element from queue is removed in constant time, because that's the topmost item. Just one simple step, first dot pop, okay, done. So in reality, you're storing it in reverse order, that's it. But now the question arises, when you want to insert in a queue, let's say I want to insert 5, it will go here in the back, means it will go here in the bottom 5. How do we do that? It's very simple, empty it. Okay, no problem. You want to insert 5, no problem. So you want to insert 5. Okay, what we're going to do is pop. So 1 2 3 4. So 1 1, then 2, then 3, then 4. Okay, that's how we remove. Don't be like, Kunal, why can't we just use normal array functions or whatever? No, it's restricted. Abstract data type, stack. Only function that they have provided us, only that we can use. Push, pop, empty, so on and so forth. Okay, empty. When first is empty, put the item you want to insert. I want to insert 5. First dot insert 5, no problem. Then empty the second back into the first. 4 3 2 1. How simple was that? That's it. Now insertion is O of 1. Sorry, not insertion. Removal is O of 1. Insertion is O of n, where n is the size of first. If you want to insert an item, it will be like linear time complexity. It will not be instantaneous. Alright, cool. How simple was this? This was asked in Google. This question is very popular in Google. On LeetCode, if you see, it also has a lot of thumbs up stars. It's a joke. These questions are like literally, it's not very cool, and yeah, let's code this. Again, try it out yourself, I'd recommend. And you can take a screenshot, you can share on socials, like these questions, such overrated questions, FANG interview questions, very easy. That's the sort of mindset you need to develop. Okay. All right, so let's code this. All right, so if I talk about this question here, yeah, you can all submit it on your own, no problem. I will use I'll do it on Replit here. So we don't have to make our own stack. I think you can use the stack that it's provided with the java.util.stack. I'm not sure if I have to import it. Let's check it. Okay, let's check it, no problem. Stack is equal to new stack. Yeah, you have to import it, I think. So import java.util.stack. Looks good. Yeah, that looks good. And we want it to be, let's say, integer. This is something we have covered in object-oriented programming. That looks good, right? Conversion from stack integer. No, it's good. It's good. All the warnings are gone. No problem. And now we can just do something like first dot push 5. No, not first, sorry. Stack dot push 5. Okay. Nice. You can say system.out.println stack.pop. All right. Let's run this. 5. Cool stuff. Very simple. As you can run your stuff over here. You can also use the terminal if you want. Okay. So we are using the stack that is inbuilt in the Java library, but we have also learned how to create our own stack. So you can do that if you want. Up to you. Not a problem. All right. So that's what we're going to do. I'm going to create a new class. I'm going to say Q using stack. Okay. Let me zoom in a little bit so you can see. Let me hide this thing. Let me hide this also. I hope you can see now. Yeah. Q using stack. Okay. Now here, all the things we learned in object-oriented programming, will be utilizing that. So we don't want people to directly modify first and second. Okay. So we will just make those private. Stack integer first, and second. Okay, we don't want people to modify these directly, so we have made it private over here. Now constructor, Q using stack. In the constructor, we are just going to initialize this. Okay, first is equal to new stack. Second is equal to new stack. Not a problem. Now, what do we need to do? Let's say we create how to insert. Is insert going to return anything? No, it's not. Insert item. How do we insert? How do we insert? We just saw in the white paper. Just if you want to make, let's say, insert efficient, then just do first dot insert. Sorry, not first dot insert. First dot push item. That's it. That is it. Okay. But if you want to, let me show you the whiteboard again. Okay. But if you want to, let's say, remove, then empty first into second, remove the top one, empty second into first. As simple as that. As simple as that. Okay. So public int remove, we are removing the integer item. So whatever item will be removed will be returned in the function. Already we have done this in the past one. And here we're going to say that while first is not empty, not first dot is empty. While first is not empty, put it in second. Remove from first and put it in second. That's simple. Now, int removed is going to be equal to what? Removed will be equal to, so you emptied all the first and second. So while first is not empty, first dot pop means remove from first and put it in second, because we know pop actually returns that item. So first dot pop, this will actually return an item. Okay, you can also save it in another one if you want, like this. Okay, but I just made things simpler like this. Okay, now int removed is going to be equal to second dot the top item, means which one? Second dot pop. Second dot pop. So this one will be removed also, and it will be in the popped variable now as well, because whenever something is removed from stack, we get that value in the returned function here. So this will be saved over here. Now only left 2 and 3. So remove 2 from second and put it in 1. Remove 3 from second and put it in first one again. While second is not empty, keep removing from it and keep adding it in first. Okay. While not second dot is empty, while this is not empty, I have to put in first what I remove from second. Same thing I did previously. In the end, I will just say return removed. That is it. It might throw an exception like, hey, it's we can just put an exception here as well. Throws, let's say, exception. You want to learn more about exceptions in detail, the classes of exception, how to create your own exception, why are we throwing it and where are we catching it or whatever. Everything in detail I have covered in object-oriented programming. So make sure you check out the object-oriented programming playlist. Nothing I will teach you that I have not already covered. I don't want you to be like, okay, Kunal, you're teaching this concept. We have never heard of it. Never it will happen in my video. Never ever. Whatever I am teaching, if it's a new concept, I will teach you then only. If it's something that might not be possible to teach during that time, I will be like, okay, I will tell you this in this lecture or whatever. If I've already covered it, I will mention that, okay, I've already covered it. So make sure you watch the playlist from first. Okay, sounds good. We can do like if it's empty or not. Public boolean is empty or not. So return first dot is empty because we are considering first as the main one. So if first is empty, then our queue is also empty. Notice that this first dot method, first dot or second dot pop or whatever, these are already present in stack. Okay, it's abstract data type. Okay, so that's why we are using, it's already present over here, Okay, so I'll share this as well. You can run my own code in your browser as well. So you can sign up to Replit and you wanna get started with the folder and everything I've created. You can just join using the the link that I've created in the description below, and you'll be able to see all the stuff we do. One thing is left, which is if you're talking about queue, then you have to let's say peak as well. Okay, so public peak again throws exception. So what are we doing over here? Peak in queue means get me the thing that will be removed first. So first will be removed first. So instead of removing it, I can just display it, no problem. Okay, while not first dot is empty it. Second dot not pop, peak. Second dot peak. This is not removed, this is peaked. It's actually exactly the same thing. You're just looking at the item, you're not removing the item. That's it. That's queue using stack. How simple was that? Very simple, right? Now pause the video and you can actually, I'll rename it. Okay, no problem. All right, I'll create another file. I'll say queue using stack remove.java. Now this is what? This is remove efficient. Should I have just copied this? Should just copy this. Yeah. Rename. I'll delete this. I will duplicate this. Now we want to make it remove efficient. Okay, no problem at all. So remove efficient here. So remove efficient means if you want to remove it, it should be just simple. Then okay, in the remove I will just say return first dot pop, no problem. That's it. That is it. But if you want to push into it, that will be like you remove all the items from here, insert an item in first, then put it back. Very simple, right? While not first dot is empty, what I'm going to do is second dot push first dot pop. Remove from second, put it in first. Now first is empty, so we will just say insert in first. That's it. And now while second is not empty, put it in first. We already did this, you know, in the whiteboard. That's it. Very simple. Is there anything in this? That's it. Similarly, you can do peak as well. Okay. Similarly, you can do peak. No, peak is actually very simple because the topmost item is the one that we want to peak, right? The one that is at the first. So we can just do stack.peak. Yeah. So peak, this one, we can just say return first.peak. That's it. How simple is that? You can run it if you want. Yeah. Okay. Sounds good. Let's move on to the next question. All right, this is a medium level question. So let's see how we can do this. So it says game of two stacks. Okay. Alexa has two stacks of non-negative integers and zero index denotes the top of the stack. Okay. So this is the first one that got in 5, fourth got in second, third got in the third place, second got it in the fourth place. So like, you know, they first inserted 5, then 4, then 3, then 2, then 1. Okay, so this represents the top of the stack. We were taking this as the bottom, no problem at all. They are doing it otherwise, no problem. Now, the challenge is Nick to play the following game. Okay, what is Nick doing? In every move, Nick can remove one integer from either of the two stacks. So they have two stacks. Nick can remove one item from every stack. So item from stack is removed from the top, meaning it is removed from 1 and 6. Like either Nick can remove 1 or 6. Okay, no problem. After this, Nick is disqualified from the game if at any point his running sum becomes greater than some integer max sum. Oh, okay. So max sum, let's say, is given 10. So if Nick is removing items from A or B, the sum cannot exceed 10. So item removed 1, then item removed 6, total sum is 7. Then he cannot remove 7 again because that will be 14. Then he can remove, let's say, 2, 1, 6 and 2. Right? That's 9. He cannot remove 3. That will become 12, which is more than, let's say, the max sum or whatever, right? So I'll explain this with an example. So what you have to return is the maximum number of moves that he can make. Maximum number of moves that Nick can make. Okay. So let's say this is what the game input looks like. This is the number of games to play. Okay. Let's say you're playing just one game. This is just the size of the first two arrays. First array is size 5. Second array is size 4. This is the maximum that you should not exceed. So these two stacks look something like this. Now Nick can remove 4. Sum so far. We can maintain a sum so far. Sum so far is 4. Then Nick can remove this 2. Sum so far is what? 6. Then Nick can remove again, let's say 4. Then sum so far is, let me put the whiteboard and let's say we do it in the whiteboard. Okay, that will make more sense. Okay, so let's say this is our two stacks that are given. These are the two stacks that are given. This is 4, 2, 4, 6, 1. 2, 1, 8, 5. 2, 1, 8, 5. Maximum sum cannot exceed 10. What are the possibilities? Let's look at the possibilities. Let's say the guy, Nick removes, let's say 4 plus, let's say in the next turn, Nick removes 2. Again, Nick removes 2. This is what? 4 plus 2 plus 2, 8. Then Nick removes, let's say 4. Then it will be 12. Okay, Nick cannot remove 4 because it will exceed. It will exceed. So you cannot remove 4. Then maybe Nick can remove 1 again. Now can Nick remove 4 or 8? Nope. Nick cannot remove it. Nick can't remove it. So answer is, how many items Nick can remove? So answer for this is 4. Yeah, that is correct. Answer for this is 4. As you can see over here. Okay. Cool. So there can be multiple ways that you can use, but how are you going to solve this problem? How are we going to solve this problem? Let's look at the thought process. So the answer is pretty simple. Actually, as I always promise you that we will look at the thought process. I'm not going to tell you the answer. Okay, I'm going to explain how I got to the answer. Okay, so in every question, this is the 40 something video. By now, we always look at brute force approach and stuff. And then we think about the edge cases. Think about the edge cases. One idea that might come to your mind is, Kunal, just take the smallest number and remove that. Just take the smallest number and remove that. Can we not do it? Can we not just remove the smallest number? No, because even though the topmost number might be small, let's say, even though the topmost number might be small, the below numbers might be much less in value. Let's say if this was something like 1111 or something, but you're like, oh no, and this was, let's say, 6, but you're like, oh no, 2 is actually smaller than 6, we will remove 2 only. Let's say this was all 222 or something, and this was 11111, like this 111. So in reality, if you're like, okay, we will just take the smallest number. Okay, is 2 smaller than 6? Yes. Okay, we will take 2. Again, is 2 smaller than 6? Okay, we will take 2. Again, is 2 smaller than 6? Okay, we will take 2. Again, is 2 smaller than 6? Okay, we will take 2, or something like this. Okay, 5 smaller than 6? Okay, we will take 5. But in reality, if you had chosen 6 or something, that would have been much more valuable to you. Okay, if here you had, let's say, here you had something like 6 again or something. Okay, or you had 5 again, let's say, for example, or you had 5 here only, let's say, if you had 5 here only. Okay, if you did something like this, 2 less than 6, yes, take 2. 5 less than 6, yes, take then 5. Let's say now you exhausted your limit. Okay, or something like that happened. Then instead you can just, remove, like, there will be so many possibilities that you might not have encountered. So it's not always the case that you always take the minimum, because you have no idea what the numbers in the below are. You can't sort it either, because you can only remove in sequence, stack.pop, that's it. So you have to consider every case. How do we do that? Okay, you have to consider case like, okay, you're given, let's say, you're given A, you're given B, okay, and you're given the sum so far, that is something you're given, and given the count also. Sum so far is something that we will be doing, and this is the maximum count. Let me write this as MAM. This is something that you have been given. You have to take into both considerations. Consideration number 1 is, you took A, you took the top element from A. So now you took something like, let's say, A you selected as it is. So you can say A dot pop remaining. B will remain as it is. Sum will become what? Sum plus the popped one. And this is the count. Sorry. This is the count. Let me explain to you in a better way. Let me show you. So since we have to take in both the considerations, let's see how that will look like. Okay. So you are given something like, let's say, I will rewrite this. Okay, and let's rewrite this. So you're given this array 42461. No problem. You can either remove from here or you can remove from 2185. Okay, you have to maintain a sum. Initially that sum is 0. Initially count is also 0, like how many items you have removed. There are two options here. There are two options. I'm just brainstorming. Option number 1 is remove from A. If I remove from A, it will be left with 2461. B will not be removed. So this will be 2185. Sum will become what? Because I have removed 4, count will be increased by 1. How many items have been removed? 1 item has been removed. Or a second way to do it is remove from B. So if you remove from B, if I make this tree, like the second option can be something like this. 1 will not change. You will remove from B. So 185. The sum so far will be the one that is removed already. 2, and count will be increased by 1. Again, this will have two options. Again, that will have two options. What is this? Recursion? Is this not recursion? Question solved. That's it. This would be very easy for people who have watched my recursion video playlist. Such in a beautiful way I have explained recursion to you that this is the joke question. I will give you an example. This is exactly like the sequence subsequence question. We did the sequence subsequence, right? Recursion video, strings topic, arrays topic. This is exactly the same thing. Isn't that what we're doing? It's exactly the same thing. If you have seen that video now, this question is like, okay, Kunal, we get it. Just code it. Let's move forward. It's a very easy, basic, joke question. That's it. Still, for people who are beginners, I'll let's say make a new tree for you. 42461. Let me see how that will look like. 42461. And 218500. 00, and let's say the maximum value you can have is 10. So 2 pointers, maximum value you can have 10. Let's say you removed from A. This is A, this is B. If I removed from A, the remaining stack will be this, and B would be as it is because we did not remove anything from it. Sum will be the one we have removed, 4. So it will be 0 plus 4, 4, count plus 1. But if I go here, this will be 10, this will be 42461, this will be 185, this will be 2, this will be 1. Now again, 2 pointers here, 10, this will be 461, this will be 2185. Now we removed 2 from here, so 2 plus sum so far, 2 plus 4, 6, count is 2. Similarly for here you will do same thing. Okay, here you will remove now B. Okay, so on and so forth. You will come to the very end. Then the very end, what will happen is the base condition. What is going to be the base condition? The base condition will be, so ideally, let's say you removed 4, 2 and 2 and 1. Okay, let me take a smaller example. No, not a small. This is good. This is small enough because small enough would be not understandable. Okay, so I went ahead and I drew this diagram, as you can see over here. Now it's much better than the previous one. As you can see now the recursion calls over here. So let's say we cannot exceed 10. So it's like, okay, let's make 2 recursion call. Let's assume that I took the first element of A in the first call, and the right hand side is like, okay, I'll assume I took the B. So if you took 4, then the sum so far will be 0 plus 4, 4, and you are one step down, means you have taken one item. If you have taken 2, sum so far will be 2. So you can see 2 is removed from this stack, and you have gone one down, you have selected one. You're like, okay, let's do another one. From this, what we have, again, we have two options. Either I can take this one or I can take this one. Okay, I took this one, it's on the left hand side. I took this one, it's on the right hand side. Both the cases are 2, so 6 2, 6 2, sum so far. Again, you have two options. You can either take this 4 or you can take this 2. Okay, if I take 4, then 4 plus 6 is equal to 10. 10 is still inside the maximum limit, so no problem. That's okay. And we have selected 3. And here it's saying that, okay, if I select 2, then 2 plus 6 is 8. 8, again 3. Again, you have two options. You can either select 6 or you can select 2. If you select 6, it will become 16. It will be like, okay, 16 exceeds 10, so this is not allowed. Count here is 4. I will just say, okay, return me 4. Here it's saying 12 is also not allowed. Okay, return 4. And here it's going to be like, here if I take this, you have two options, either take 4 or take 1. If you take 4, then it will be 12. So again, this will not allowed. Then okay, this will be ending over here. Again, return 4 or whatever the count is. And then here it will say, if you take 1, this will be 9. 9 is good. 4, it's fine. Now if you go here, it will be like, can you take 4 or 8? You cannot take either. If you take 4, it will become 13. And the step over here is 5. Okay, then return 5. This will also return 5. Similarly, for this right hand chord also, it will do the same thing. Okay, so you're returning the count. If the sum so far is greater than the maximum value that is allowed, then return the number of, like, the count that you have. Okay, so if you talk about this path, this path consists of 4 2 4 6. 4 2 4 6. This is what it consists of. This consists of 4 2 4 6. Okay, so the idea is like, okay, Kunal, I, let's say, took the left one or I took the right one. The answer is, what is the maximum number of items you can take in? So what are you going to return? You are going to return the maximum of these two items from left and right. What is the maximum of 4 and 4? It's 4 only, so I will return 4 here. What is the maximum of 4 and this will return, sorry, 5 and 5? It's 5. So I will return 5 here. What is the maximum of 4 and 5? It's 5. I will return 5 here. What's the maximum of 4 and 5? It's 5. I will return 5 here. Then I will return 5 and whatever this is, maximum will be 5. But 5 is actually not the answer. 5 is where the condition broke. 5 is where the condition broke. So if I talk about 5, it's actually this thing. We talk about 4. So 5 basically means this is, let's say if I take red only, 4, then 4, then 2, because sorry, not 2, 4, then so I took 4, then I took 2 again, 4 2, which gave me this. Then I took this 2, which gave me this. So something like this is happening, right? And then from here I took 4 again. No, not 4 again, sorry. I took 1 again. It gave me this. From here I took either 4 or 8. So 4 2 2 1 4. This is actually what we have returned here for 5 or 1 8 or whatever. But the thing is, the answer in reality is this, because this is something that led to us increasing in the sum. So we have to remove this. So the answer in reality would be whatever value has returned minus 1. Not 5 items. Actually 5 minus 1, 4 items we can take maximum, because the 5th item is breaking the condition. That's it. So if you have understood recursion, this is a very simple problem. It's just a sequence subsequence problem, and now we can code this. Let's code this. Okay, time complexity and stuff is also, you can calculate based on the subsequence problem. It's very simple stuff. And one more thing, if we talk about, Kunal, optimization, how do we optimize this? So in the recursion playlist, I told you every recursive program can be converted into an iterative program. And in that, you can apply dynamic programming. So I will not teach that to you right now. We will learn that in dynamic programming. We will come back to these questions. We will come back to the sequence subsequence questions. We will come back to the maze problem. We will come back to the n-queens problem. All the questions you have done in the past, you will be able to solve in optimized way in dynamic programming. I don't want to rush it. I can't teach you dynamic programming right now. It will be very difficult for you to understand. Okay, so let's learn about this for now, recursion. But we will do it in dynamic programming. Okay, so let's code this thing, and I'm going to create a new file. I'll call it 2stacks.java. Public class 2stacks, and just for demo purpose, I'm putting it here like this, but you can import individual files. What are we doing? So imagine what are the main things? Main things are 2 arrays and one, this thing. What do you call it? The maximum sum. So let's say we have that as a main function. Okay, that the person can call. Because when someone is calling, you don't want them to insert, 0 and 0 also. This total sum so far and the total count. No, this is something that should be done internally. Okay, what is the user providing? What is the user concerned with? This sum and the 2 arrays. That's it. Sum and the 2 arrays. Fine, you can include this as well later on when you want. But I'm making things simple by only taking the 2 arrays and the sum. So only the 2 arrays and the sum that it should not exceed, which is x in this case. And the 2 arrays. No problem at all. So this is what the person will see. Now, what we are going to do is, we are going to return the answer. So the answer is going to be, oh, I forgot to add the name. So we are going to take the answer, which is another function, same name. We did something like this in recursion. We call it helper function. Now this is going to be private. And this is going to be this function, the recursion call one. Okay, so it's taking it's taking what? The sum that we have, int a, array number 2, sum so far, which we are taking as sum, and the count, which will be initially 0, 0. Okay, no problem. So it will be x, a, b, 0, 0. This will be my answer. This will be my answer from here, this returned value. But in reality, this is not my answer. My answer is whatever you get from here, minus 1. I don't have to explain this. We've already covered this. Minus 1, no problem. This is the recursion call now. Very simple recursion call. Okay, take 1, take 2, and that's it. Return the maximum. Take 1, take 2, return the maximum. So here what I'm going to do is base condition. If my sum is greater than the allowed sum, I'm just going to return the count. Like we returned 5. Like we returned 5 over here, 4 over here. Okay, that's good. Now I'll take my answer number 1. Let's say answer number 1 is equal to, you make the call in the left hand side. So 2 stacks, I'm making a recursion call, x will remain as it is, a will be, actually I have to now remove 4 from a, remove the first element, means I take array from index number 1. There's a very nice function you can use for this, arrays dot copy of range of array a from index number 1 till the end. This will slice it, means this will, like, it's a Python term, but this is what it's going to do is it's going to remove the index at 0. It will take from index number 1. That is what we want. See, remove this thing, take only this from index 1. So this function allows us to do that. Okay. And b will remain as it is, no problem at all. Sum will be what? Whatever thing that was sum, whatever it was, plus whatever thing that was removed. 0th element was removed, count will be +1. That's it. Similarly, I can copy this and I can say my answer number 2 is equal to, A will not change, I will take B instead. That's it. Now I will just do what? I'm going to return the maximum of these two answers. From left and right, whatever maximum you are getting. That's my answer. One more condition you have to put, if, because you keep on slicing these arrays. What if one of these arrays become empty? Then also you can't go more further, then you will just return the count. So if a dot length is equal to 0, or b dot length is equal to 0, any one array becomes 0, empty, just return the count also. So because how many elements you have taken that till that point, that is the only thing that matters now, because array is empty, you can't take more elements. That's it. Yeah, that's the question. I believe you can run this on your own. It's actually very simple, right? I won't write it down like in the, let me just write it down, but I'll cut it in the video because I don't want to waste your time. So you are past all these things. You are on lecture 40 plus. These, like, calling the file and calling the function should be like piece of cake for you. Like, Kunal, okay, fine. You wrote the main code, we will call it. Don't worry. But still, let me show you. Okay, now we're going to run this. So here you can see I've created the main function. It's very simple. It's taking the number of test cases, then running the loop for that many times. So it will take this line, the number of times you have the test case. If it's just one, then it will run the loop once. It will take these 3 lines. It's taking the size of A, B, and the sum. Taking the size of A, B array, and the sum. And then it's taking both the arrays, and then it's printing the answer. If I run this, I will see, oh, we're getting this error because, see, that is why you should copy paste carefully. So I copy pasted this file, but instead I forgot to rename. So this will be remove. Remove, and that's it. Okay, so in order to run this, Replit runs the main files. So you can just, name this as main if you want. Okay, and you can also see the history in the bottom right. Here, if I, you can format the code. You can see format 2 stacks. So if I do it like this, and then I saved it, so you can see it formatted it automatically. So you don't have to worry about indentation and stuff. So I run it as main. I'll just do run. Okay, and I'll put 1 here, then I'll put 5, 4, 10, 5, 4, 10, and I'll put 4, 2, 4, 6, 1, 4, 2, 4, 6, 1, then I'll put 2, 1, 8, 5, 2, 1, 8, 5. Answer is 4. Answer is 4. Very easy. Very cool. Alright. So yeah, pretty cool stuff. So you can check out the history as well over here in my REPL. And you want to access this, you can just check out the Replit link in the description below. And you can sign up for free and you can try it out. And yeah, I've created a folder. I'll make folder for other things as well. So the good thing is you can directly run my code, and you can make changes in it and do all sorts of things. So it will save you a lot of time. It's good for collaborations. Okay, cool. Let's move forward. All right. So next question, it says it's lead code hard. But as you know, there's no such thing as lead code hard because you're watching my DSA playlist. So this is actually a lead code easy question. Very popular question asked in Google and other big tech companies. So very important question. but very, very easy. So this we'll have fun with this question. Let's dissect it. Okay, let's have fun. Let's see what they're asking. What is the thought process going to be? How are we going to come up with the solution? I'll give you some important tips in this question that will not only be for just this question but other questions also. Tip number one is, when you're given such problems, okay, or not such problems, any problem that you feel like you might get a feeling like, okay, little bit challenging, I'm not understanding or whatever. Some of the best practices I recommend is, first of all, just pen and paper. Okay, see what they are asking and identify the patterns. We all know that. Okay, so I don't have to explain it. But one point I would like to give you is, this is an important point. Separate the algorithm from the worker functions. What I mean by that is, let's say we have some algorithm. So let's say, what is this question? So it's saying, given an array of integers of heights, so this is an array of integer of heights, these are like tars, representing the histogram's bar height with the width of each bar is 1. Okay, width is 1. Return the area of the largest histogram. Okay, so one area, like if I take my pen and paper, okay, let's take pen and paper and let's explain this, and let me give you some tips on how to approach such problems or any such problems. Okay, let's see. It's going to be very simple. I'll tell you the thought process. Okay, let's assume that, let's say that this is our stack. Okay, and it's saying that find the largest area in the histogram. Okay, no problem. If I just if I zoom in this a little bit, there we go. Let's say I zoom in like this. Okay, not a problem. So the idea is that what are the possibilities of areas of rectangles that I can have? One possibility is this one. Not a problem. Okay, imagine, because you can't have a rectangle like this, right? Okay, we can't take this one because this is an empty section over here. Empty section over here. So pretty self-explanatory, this thing. Okay, all right. Point number one, tip number one, every question it will help you. Before thinking how we are doing things, think about what we are doing. Kunal, why are we taking this? Okay, that's a good question. But do you realize what we are doing? Most people don't do that. Okay, let's just ask, okay, why are we doing this? What is, okay, you're asking why, but do you understand what we are doing? Most people don't even know what you are doing. First understand what you are doing, okay? Another question can be something like, let's say, this is also one possibility. Isn't it true? This is also one possibility. So let's think about it. So there are two ways to it, 2 pointers. Point number one, how do we know what to use? How do I know that we are doing stacks and queues? Then how do you know that stack are being used? Because you have been watching this video since the start, and in the start I mentioned, whenever you have something to do with sequences, answer till here, stuff like this, answer till here, something I'm keeping in the back, needing items in the sequence, in that case stack and queues is used. That should be your queue. Because if you look at it from an approach like just brainstorming, just trying things out, see how it will work, you're like, okay, first I will be like, I'll start from here. Let's say I'll start from here, 0, 1, 2, 3, 4, 5 indexes. Okay, I'll start from here. I'll be like, okay, if I'm at 0th index, then what is the maximum area I can have? Okay, let's say I can have 2, no problem. Then I will start from 1. What is the maximum area I can have if I am here at 1? So till 1, the maximum area I can have is again 2, not a problem. Again, what is the maximum area I can have when it comes to 2? So I can have 5. I can have 5. That's it. Because you can either have 5 or you can have something like this, which is 3. So 5 is greater than that. So 5 is the answer. What is the maximum area I can have from 3? From 3 I can have something like this. Okay. From 4, what is the maximum area I can have? I can have something like this. Okay. This is including 4, but in reality, if I talk about from 4 till like the very end, what is the maximum area I can have? I can have this one. This is the maximum one. Okay. So the idea is that we know that we are taking maximum so far from one index. We are taking maximum area that we can get from one index. For that, we'll be using stack. Awesome. Simple. Sounds good. That's it. Problem solved. This is really a hard question. It's not. This is not a hard question. But the real challenge is, how do we do it? Okay, we know stack is being used. We have gotten the hint that stack will be used because we are taking answer so far. Such questions where you take answer so far, high probability stack will be used. But how? How are we going to do this? So let's say we have these indices. Okay, and we need the answer till that index. Let's say we store the indices in the stack because that's what we need. And one thing I want you to notice is that how we are calculating this area. Think about the edge cases. Think about the edge cases. So for every I, I'll be like answer till that. Okay, maximum answer till that. So in that case, I will be something like, I'll say that maximum answer for that I that I can take, including that I. So including that I, if I take about example, I is equal to 4. So maximum including this I, from this I can have something like this. Okay. Sounds good. From 3, the maximum I can have is something like 6 only because I'm taking it from 3, including all the 3's and everything. Including 3, I'm saying. Including 2, the maximum I can have is something like this. Including 1, the maximum I can have is something like this. Okay, so on and so forth. So one thing I want you to realize is that that won't really work out. What really we need is, if we're taking maximum answer till that point, it should consist of all the things in between. So for example, maximum answer if you're at 4 has to be okay, I understand. So we are brainstorming now. So let's say your idea, we know half of the problem is solved. How the problem is solved? Because we need, let's say, max from each, not from, till, max till each index. We need max till each index. Till 4, what is the maximum you can have? Till 3, what is the maximum you can have? Till 2, what is the maximum you can have? So that is what we need. And how are we going to figure that out? How are we going to figure that out? If we talk about 4, then max till 4 can be, what are the possibilities? You can either have 10 or you can have something like, let's say 1, 6, just writing down options, or you can have something like, let's say if I talk about till 4, means let's say not including 4, behind 4 or whatever. You can have something like this, 4 also. Okay, so if I'm talking till 4, okay, let's say we talk about till 5, okay, till 5. So till 5 means this. What are the possibilities that I can have till 5? Okay, we can write it down. Possibility we have is, one, we have this, another we have this possibility, another we have this possibility, right? Make sense? Make sense? So what I'm doing is, till every I, I'm considering the maximum option that I can have for every single index. No problem. We are just doing the thought process right now. Okay, I haven't even started solving the problem. So I'm like, okay, till 4, I will calculate that what is the maximum that I can make from 3? So 3, what is the maximum I can make from 3? So yeah, problem solved. I just got it. Okay, problem solved. So that's very simple. So let's see. Maximum till each index and then take the maximum of whole. That is very simple stuff. Like that is something that is in the given in the question. Okay, but how are we doing that? That is the challenge. So okay, I got it. So if I talk about maximum till maximum, like if I talk about from 0, okay, or start from 1, let's say till 1 means not including 1. Till 1 means from here to here. What is the maximum that I can have? If I talk about from 1, sorry, till 1, what is the maximum I can have? I can have 2, no problem. Okay, move forward. If we talk about this now, before 2, what is the maximum I can have? Okay, so till 2, what is the maximum that I can have? You have two options. You can either take what is the largest area being covered by 1 and what is the largest area being covered by 2, means this one and this 2. So if I talk about this section, then you can either have a section of this, which is equal to area 2, or you can have a section of this, which is again area 2. So answer is only maximum of this, which is 2, maximum of this. Okay, no problem. Now let's talk about 3. Till 3, what are the options that you can have? Okay, till 3, if I take what is the maximum that I can make from 5? Maximum I can make from 5 is, I cannot go back, I cannot go front, only 5 only. Okay, other option is maximum I can make from 1 till 3. This is what I can make from 1, 3. Other option is maximum that I can make from 2, just 2 only. Maximum of this is 5. Okay, so answer so far is 5. No problem. Let's move forward. Now let's talk about, if I talk about till 4, means this thing. So till 4, what are the answers that I can have? Maximum I can make from 6. This bar, maximum I can make from 6. I cannot go left, I cannot go right, so only 6 I can make. Okay, maximum I can make from 5. I cannot go left, but I can go right. 10. Next problem. Maximum I can make from 1. Maximum I can make from 1 is 4. Maximum I can make from 2. Maximum I can make from 2 is 2 only. Maximum of all of this is 10. Answer so far is 10. No problem. Move forward. Now, here also, they do again for every single index. Now, here it's be like, okay, maximum I can make for 2. Maximum I can make for 2 is, I cannot go right because it's answer till 5. So, not including 5. So, I can't go right. I can go left though. No problem. I can go left. So till 5, I can go left. So 6. So on and so forth. And for 6, the maximum is I can't go left because nothing is greater than 6 just by adjacent to me. I cannot go right. So 6 only. Then for 5, I cannot go left, but I can go right. 10 because this thing, right? Maximum again you know, for 1 it's now I can't go 3 right and 1 left, so 5, and for 2 it will be 2 only, so maximum is again 10, which is unchanged. Similarly for 3 also, here let's say you're taking now the entire array. So for entire array 3, you cannot go right, you cannot go left even, so you can only take 3. Okay, till end means till 6, 6th index outside. Till 6, I can only take, for index number 5, I can only take 3. For index number 2, I can go 2 left and 1 right, no problem. So I can take 8. And then for 6, I cannot go left, I cannot go right. For 5, I cannot go left, but I can go 1 right. For 1, I can go 1 left and 4 right, which is 6. And then for 2, so answer is 10, which again unchanged, our answer is 10. That's it. Answer 10. Very simple. Nice. Problem solved. Okay. Sounds good. Cool. One thing I want you to realize is now how are we going to do this? How are we going to code this? How are we making this? Now only problem left is now that you understand the thought process, right? You understand how we came up with stacks. You understand how we are taking the maximum till that point, because that's what we need, because we want to make sure we cover all the mini and all the rectangles that we can have. This will solve every single case, because we are taking for every single answer till that point. So till point number 4, for example, till point number 5, what is the maximum answer you can have? Is this not covering all the test cases? It is covering all the test cases. I just showed you for every single test case I was scribbling. We are making sure that the maximum area we are making. So if I talk about 2, I'm making sure that, okay, I'm taking all of this area. Or if I talk about, let's say for entire 5, I'm making sure that I'm taking all of this area. Okay, but how do we make sure that happens? How do we make sure that happens? Let's see how we are going to do that. So we are, let's say, we imagine we are at this I position, let's say till 3 or till 4 or whatever. Let's say we are at 4. Okay, so how do we make sure that we are taking all of these cases, or better, do we need to take all of these cases? Let's think about that. So let me think. We are at 4 and we are like, okay, till 4 we have to take like this example, for example. Okay, so one thing I can do is that here we can see that it doesn't really make sense. You can see here, it doesn't really make sense to do index number 2 till index number 3, because this is increasing order. Can you see that? Because if I talk about till 4, which is 6, 10, 4, 2. Okay, and I talk about till 3, which is 5, 3, 2. Okay, I know that the adjacent one, I know the adjacent one is greater than the current one. Then can I not just be like, okay, if this is greater, then I know I'm going to take it. Why can't I just take it? Why should I calculate? So idea is that if I'm calculating for these 3 and I know that this one is greater, then can I not just include this? Can I not just include this? I can, because I know this one is greater. Because I know this one is greater. Because it will just be repeating the steps. So what you can do is, let's see how we're going to do it with stack. Answer till now. Let's see how we can do it in with stack. Let's see. Okay, let's see how we can do it. Let's say index number 0. Answer till now. We want that 1, 2, 3, 4, 5. Let's say we use a stack for this. Okay, so let's say first we have 0 in the stack, and I value and my answer till now, or maximum value. I can just put max over here. Max till now, let's say initially 0. Let's say we start with 1 because 0 is already in the stack. Okay, so before 1, what is the maximum answer that I can get? So before 1, I only have 0 only. So maximum I can get is 2. Okay, no problem. I removed 0 from the stack. And I insert I inside it. Now I value is 2. It's going to be like, hey, what is the maximum you can have till 2? It will like, maximum from till index number 2 is actually this. But I know that the item right next to the I, which is 5, is greater than 5. Then with common sense, I know that I can include this also. Common sense. Okay, because If the item is greater than, if I am over here like I, okay, and I is equal to 2, for example, not I, sorry, the peak one, the stack dot peak means the one at the top of the stack before I. So before I have over here, okay, and it's saying that this is actually the smallest one till I that I'm having over here, the smallest one till I, and here it's saying that if you're taking this, just take this also, na. Consider the next one also. Forget that. Consider the one after that also, which is this. Forget that. Consider this also. Consider this also. So for 1, I can consider all of these. Are you able to understand? I don't think you are. Let me think how I can explain it even more clearly. So let's say we do that. Let's say we have 1 over here, and let's say we are at I number 2 now. So we need till 2, the maximum answer that we can get. So we know that it's going to be 2 because it's going to be whatever I value you are at, in the previous ones over here. But one thing I want to see is we don't want to make irregularities. I don't want to be like, okay, if this is 2, I don't want to, how are we going to do that in with that thing where we are taking, the left, how much left you can go and how much right you can go. How are we measuring that? So brute force approach, you can just do for loop, okay, how much left, how much right. I'm trying to do a little bit more optimized solution. So the one we did above, this you can code yourself now. This is very simple. Okay, for every index I, how much left you can go, how much right you can go, no problem. But that is not an optimized solution. The common sense thing, we have to figure out what the common sense might be. So if we're taking the maximum items, okay, if you have the maximum items, let's say this is increasing only. So let's see what are the edge cases here. Okay, so imagine we are over here. We need till I5 means we need this till here. So if we're talking about till here, then I have to figure out what is the, if I talk about let's say till here, then I have to figure out, let's say for 2. For 2 I have to figure out left how much I can go, right how much I can go. So right how much I can go will be the maximum, the first one, that is, let's say the maximum till. So let's say if I talk about till 5, right, and I talk about let's say 1, okay, so I have to talk about what is the last element, that is the maximum, that is the largest one of 1, more than 1, okay, and not less than I, because we're taking inside this red boundary. So I know that what is, if I go right, what is the maximum that I can get before I reach a limit where the item is less than 1. Reason being, if you find an item less than 1, let's say we have 0 over here. If we have 0 over here, then what is the maximum that you can go right? Okay, maximum I can go right over in that case is just 1, because this is 0. I cannot take 0. This will be empty space. You get my point? So maximum that I can go right in any case will be equal to what? The item in non-consecutive order that I have, that is greater than I. Sorry, not I, greater than 1, let's say for example in this case. And that is going to be somewhere over here, which is till 2. And obviously in this boundary. So this thing. Similarly, like till left, how much you can go? Till left, I can go till left till I find the all the bigger items than I, for example. So here I can go also 1. Okay, so that's one approach to look at it. If I talk about 2, let's talk about 2. How much you can go right? I can't go right because we are already here in the case. How much I can go left? I can go left only 2 times. Means find the first smallest item for the point you are considering. If I'm considering 2, find the first smallest item for 2. That will be the elements you can take in the right hand side. So if I take the, let's say, entire array, okay, you're at the edge case where you're at the case we're taking the entire array, and you're considering for 2 what is the maximum amount you can get. See, because this case, this last case, okay, you can do it for every case, but I'm taking the last case for simplicity. So let's say you had 1 over here, okay, no problem, you had 1 over here and you're taking it till 5. Okay, now you will understand. Okay, this is something we did previously, no problem, we know we are doing this. I am explaining how we are doing this now. Okay, it should not be a concern about what we are doing. We know what we are doing. We are taking maximum till that point for every sub part, no problem. So how are we taking that maximum? So if we're taking this sub part, then I'm thinking about, okay, this sub part, no problem. For 2, what is the maximum you can make from 2? Obviously you'll do it for everyone, for maximum till 3, maximum till 2, maximum from 6, how much you can make, maximum from 5, how much you can make. So if we talk about maximum from 2, how much I can make, so I have to find the largest item in the right till that, so that is 3, and the last largest item from the current one in the left as well. What is the last largest item? 6 is larger than 2, yes. 5 is larger than 2, yes. 1 is larger than 2, no. Stop here. That's your answer. Okay, so in a way what we are doing is, we are taking the, we have to store the smallest item from the last, from the left hand side, from starting the smallest item, and from future the biggest item. Nice little sun in London, which is very rare, so that's good. Okay, so smallest item in the left, next largest item in the right. Is this not ascending order? This is ascending order. This is something called as ascending order. What's the problem? No problem. It's ascending order. You will take all the items. Okay, it might not be strictly ascending, but I know that all the items in the middle over here, they have to be greater than equal to 2. This also has to be greater than equal to 2. These can be unsorted. It can be something like 4 over here. But I know that we are taking maximum till that point. For that I have to consider, for this point only if I'm considering, I have to talk about the last item which is smaller and the last item that is over here again smaller. Okay, so if I talk about 1 over here, so this is smaller, then I will take only till here, and again this is smaller, then I will only take from here. So this will be my answer. Okay, sounds good. So let's see how, let's again brainstorm it a little bit. So let's say we are at answer number, index number 2. So till index number 2, what is the maximum I can have? I will again take out, I know that this is going to be the minimum one right now. Let's say minimum 1 till 2 is going to be available like over here at this index in increasing order. So I'll be like, okay, you're at index 1. From 1, what is the maximum you can make? So from 1, the maximum I can make is, if I empty this, and let's say this is the now it becomes empty. So if the stack becomes empty, then I can take it right from the start. So I can say 1 into whatever I you have, which is 2. So 2, that's correct. That is correct, no problem at all. Okay, no problem at all. Now I will be equal to, yeah, but that's the case, that's the thing. I will now be equal to, let's say 3. And again, if I put, let's say we have 3 over here and we're taking till 2, then again I'm taking for 5 and I'm taking for 1 again. So if I'm taking for 1 again, it will be this. But since I know that it's like increasing order, then instead of taking this case, I can just skip this case, because this case will come inside this case. This case will come inside this case, as long as the ones next to it are strictly ascending. Okay, I can't take this one over here. I can't take 2 over here. Right, because I will take 2, but I will take it one by one. For now, I will only take till whatever I you are at, right? Only take the increasing ones, because that's something that you can already consider. So if I talk about, let's say you are at index number 1. Okay, you are at index number 1, and let's say initially 1 was available over here, but now you are at index number, let's say you are at index number 2. Okay, index number 2 I know is greater than 1. I will just push it over here. Now you're at index number 3. I know that is also greater than the previous one. I will push it over here. Sorry, not previous one. It is greater than it is greater than the previous one. That is what we need to take. Now we are at index number 3. Let's say we are at index number 4. Is 2 greater than 6? 2 is not greater than 6. So now we will consider this case till 4. Now we will consider this case. So basically find chunks of items that are strictly increasing. Find chunks of items that are strictly increasing like this. Now this line would have made it clear. Strictly increasing items. Okay, because that's how I will make sure that I can take all the lefts and all the rights. So now let's say if we run this program, so 4 is available over here. So for 4 is available, then I take the first item that is like behind 4. That is, let's say, that is what, 3. Index number 3, which is 6. For 6, if I remove, what is the answer that I can get? So answer that I can get from 6 is till I, means I minus 1. So basically answer which is answer till 4, which is for 6. So 6 into this block into how many cells I can take. Right hand side cells I can take is I minus 1, which is equal to 3, minus the smallest item that I had. Smallest item that I had in the left hand side. So the next smallest item that I have in the left hand side is peak value. Again, take the peak value. So peak value is always considering the next smallest item that you have, which is index number 2. Index number 2, okay, minus 2 means this one, which is equal to 6. No problem. No problem at all. Okay, maximum so far is 6. Now, maximum so far is 6. Now we talk about, okay, is 2 less than if index number 4 is this thing, index number 4 that we are at right now, is this less than the next smallest item in the stack, which is 5? Yes, it is less than this, then I can consider it. So if it is less than this, then I can consider it till here. I can be like, okay, answer is equal to now 5 into how much right I can go. I can go till I. So which is I minus 1, which is I minus 1 is equal to 3. And how much left I can go? What is the next smallest item, which is peak, again 1 minus 1, this 10. Answer so far is 10. Make sense? Right? Sounds good. Similarly, now I will do for 1. I can't remove 1. I'll be check, hey, is 2 actually, smaller than 1? It's not. Okay, then just put 2 inside. Is 3, now I will be equal to 5. Is 3 smaller than the one that I have on the stack? No, it's not. Put it. Actually, I'm not putting the index values here. I have to put like, this was P4 index number 5. Now I'm at the end. No problem. Now I'm at the end. So if I'm at the end, I'll be like, okay, take the last smallest item. So the last smallest item in this ascending order stuff. So you can see again we added the ascending order over here in the stack. Okay, that's what we're doing. Because we know it is ascending, though I know where I can take it like this. But the ascending structure breaks over here. That's why I did not put all of these three inside at once. And we know that since it's like ascending order in order, okay, and I know that the smaller ones are getting removed, then I know that it will be having in increasing order like this. This will be the smallest one. Okay, this last one, the element at the zero, at the very last of the stack, inside the stack, will always be the smallest item till I, and it will keep on increasing in this way. Okay, because if there was something possibility that was smaller than this, then these bigger items would have been removed. So always I'm maintaining the smaller order. Okay, now if I talk about 5, let's say I remove 5, so I remove 3, what is the maximum that I can make? Right, I cannot go that much, so I will only say 6, which is the I minus 1. I is equal to 6 right now. 6 minus 1, 5. Minus how much? If I'm at 3, how much left I can go? Find the next smallest item of 3, which is at index number 4. Which is at index number 4 here available. That is why I'm adding the increasing direct orders. Okay, index number 4 available over here. Okay, 4 minus 1. Sorry, not just 4 minus 1, just 4. So 3. No problem. Now 5 is removed. Now I remove 4. So index number 4, I remove 2. 2 into what is the, I know that this is the, if I'm talking about I, then every element that I have, this element that I have till I will be smaller. Okay, it will not be as like, greater than I, because we would have considered it then. Okay, so this is like small, then I can take all the right hand side ones. So take all the right hand side ones in every case. Till I will take, so I is 6 minus 1, 5, minus, what is the left, what is the next smallest item? Next smallest item is in my stack, which is at index number 1. Index number 1, no problem. Index number 1. So this thing. Sorry. This thing. I hope you're understanding. The next smallest item thing is very simple. The next smallest, I will just peek it. So in this order, you're taking the next smallest. Okay. Smallest is, let's say 3. Smallest is index number 5. Index number 4. Next smallest is index number 1. That's how you're doing it. Increasing order. So this stack is making me easier to find the next smallest in the left. Next smallest is just the item below it. Next smallest is just the item below it. Because all the ones that were in the middle were popped when we were calculating it. Okay. Simple. So that's it. Right? One doubt you may have, okay, Kunal, we get it. This is ascending order of the next smallest item in the left hand side. But how about you are doing it with the right hand side? Okay, how are you doing it with the right hand side? So right hand side is pretty simple. In the right hand side problem, till I am only taking it till I, because I know that I is actually smaller. I know smaller than the item I am currently at. That is why I am taking it till I. If I talk about 6 and I am at I is equal to 4, then I will take it till 4. If I am at this one, I know that 5 is actually smaller than the bar 2, then I will take it again till I. If I am at then again this one, I know that I is actually greater than this one. I is actually greater than this one. Then I will include I in this. And that is why I did not calculate anything and I just added 4 in it. Yay. Now I understand. Okay. Makes sense. So now you will be understanding the right hand side also, what I did with right hand side. Okay. The whole idea is how to find the next smallest in the left and next smallest in the right. That's the idea. That's it. That's all you need to do. That is it. And that is how we're doing with this stack. Okay, repeat, watch this video again if this option is not clear, but I explained it very detailed manner, and that's the best way to understand this. Okay, I explained to you all these. Let me tell you what I explained to you. I explained to you what we are doing. I explained to you how we are like taking chunks of data. Okay, chunks was very simple stuff. There was nothing. The real challenge is how we are doing it. So how we are doing it is we are taking till I. Till I, what is the maximum I can make for every bar? Maximum I can make for every bar is common sense. Take the till the left. I will keep on taking from the left till I find an item that is smaller than that. Okay, for example 2. I will keep taking in the left till I find an item that is smaller than that. Similarly for right, I will keep taking the items till I find something that is smaller than that, or it becomes empty. For example, in case of 5. In case of 5, I will go in till right till I find an item that is smaller than 5. Keep going till right. I found one item 2 that is smaller than right. Okay, then I will stop here. This is my answer. Okay, and how are we doing this? We are actually maintaining this in the stack. If you want to find the next smallest item will be in the stack. Okay, and if you find the next greater item, then you don't have to do that. You can just keep adding in the stack. Keep adding your items like in the stack, and it will grow automatically. Okay, and you will only stop the stack to perform the calculations when you find a particular element. For example, 2, this index number 4, that is smaller than the item at the top of your stack, which is, let's say, in this case it was, I had 3. So we had 3 over here, something like this. We had 2 over here. We had 3 over here. I was now at index number, let's say, I was over here, and I was like, okay, is 2 actually, smaller than the item that is at the top, which is 6? Yes, it is. Okay, stop right here, calculate maximum till here. In this case, I can take all the items in the right, because I know that there is not a single item. I know there is not a single item while I am calculating that is smaller than 2. And when we do find that item, we will stop. So for example, I considered this element. I'll be like, okay, I have found a particular index that is smaller than the current item on the top of the stack that we are considering till then. Okay, no problem. Then I can take all the ones in the right. There is nothing in the right, so I will take nothing, just 1 available over here. Take all the ones in the right and take the next smallest in the left. Next smallest in the left is the next item in the stack, which is 2. Here, this is the answer for 6. So sorry, not for 6. Not this is the answer. 2. Till 2 means something like this. Here till 2. Till 2 means here. So this is the answer for 6. Now 6 is out of the stack. 6 bar. Now we talk about 2. So index number 2 is 5. Is the current index that I am at 2? Is that smaller than 5? Yes, it is. Okay, then stop right here and consider till 5 only. Consider till 2 only, because I can't include 2 because it will go again like this otherwise. So you're like, okay, stop here. Consider just till 2. Till 2, calculate the answer for 5 now. Till 2 for 5 I know is that since I know 2 is the next smallest item from 5. It is the next smallest item from 5. In that case, I can take all the items in the right till I. All the items in the left till I is only one item, which is 6. Okay, and I can take the next smallest item in the left, which is equal to, again I do stack.peep. The next item is 1. Okay, so till take 1. So this is my answer. No problem. Okay, 10 is the answer. Now I consider for 1. It's like, hey, is 2 smaller than the item at index number 1? No, it's not. It's actually bigger. Oh, okay. In that case, you don't have to consider till I and the next smallest or whatever. Till I, you don't have to consider. You can just include this only because this is missing, right? Because I know that this is greater than this. So this will obviously be included in the answer. So I'll just include this over here, because when I come back to this point 1, this 2 will be available in the stack. And in that point of time, I will consider this. Okay, sounds good. And for example, when only one item is remaining in the stack, we know that that is the smallest item in the array till that point. Since it's in increasing order, we know that this is the smallest item till I. At any point of time in the stack, from the below, it's increasing order, and the below one item is the smallest item in I. Smallest item in I. Okay, hence, when you remove a particular item and the stack becomes empty, because we know that the smallest item in the I is at the very bottom of the index of stack. And when we pop out of the stack and the stack becomes empty, we know that the item we just popped out was the smallest item, obviously the last, the smallest item till that entire I. So in that case, the area would be just I into whatever that is popped. For example, it was in case of 2, this one, 0 index. So I put 0 index over here and I pop 0 index out, stack becomes empty, I was equal to 1. So I know that till 1, this is the smallest element. Yeah, 2 is the smallest and 1 into 2. No problem. It's very straightforward stuff if it's in increasing order. That's it. Try to debug it and let's code it. Let's code it now. That will make it much simpler. So one thing when I recommend coding is separate the worker stuff, like how we are calculating and everything. Separate that from the logic in your code. It will make your life very easy. Let's code this. Okay, so here we have our file, the thing that we have, and I'll create a new file. I'll call it largest area histogram dot java, and what we are doing it public static void main. So we'll do this thing later, but I need to get my answer. So if I go back to lead code, this is my answer. Okay, int heights. So here basically what I can do is I'll have to create a stack first of all. Stack of integer stack is equal to new stack. Okay, maximum current is equal to 0. In the end, just return maximum. No problem. Now initially I will put 0 in my stack. No problem. And okay, now what we're gonna do over here, as you can see, is we have this. Now we'll start a for loop from I is equal to 1, I is less than what, heights dot length I plus plus. So the stack basically going to contain smallest item till I, all the small items till I, all the items till I that are, if I'm talking about 2, then all the increasing order items. Okay, increasing order items. So while I will say stack dot is empty is not the case, while stack is not empty and the heights of I, if I take an example of 2, if this is actually smaller than all the items that are in the stack that we just considered, so stack dot peak, if this is smaller than heights of, I'll close this, heights of stack.peak, if this is smaller, then I know I can stop there and I can just, calculate the max. For that, we can create another function, get max. This will take my heights, my stack, my max, and my I. And in the end, I'll just say stack.push. I'll push I in it, no problem. Also, when we are done traversing the array, so in this case, like we're done traversing the array, then we need to do this thing again for every single element that is in the stack. Every single element that is in the stack. Okay, so we are not doing it for every single element till I. We're only doing it for every single element till I that is like smaller, that we can consider like to be next smallest. Okay, I already explained this thing to you. So for that case, my I is equal to heights dot length, again while stack dot is empty, just take the max. That's it, problem solved. Now we just have to create get max. How are we taking the maximum item? It's very simple, not an issue. Array I, no problem. And let's say area initially. In the end, you can just return math.max, current max, and the area that is from this point. What is the maximum area? So int popped is equal to stack.pop, top item removed. What is the, like if stack becomes empty, I know that this is the smallest item till I. Then if it is the smallest item till I, then I can just take it for the entire I. For example, if it was 1 over here, okay, and my I was somewhere over here, let's say 5. So I know 1 is the smallest item till I, then I can take it till I, entire one. Okay. And I will just say area is equal to ARR of popped into I, no problem. Otherwise, area is going to be equal to what? ARR of popped multiplied by what? It was, first of all, what was this thing when it is removed? I know it was the from I, it was the from I when I removed this. So if I removed, let's say if I'm at 4 and I just removed 5, so 5 means that there are no smaller item than 5 between 5 and I. So I minus 1, and the next smallest item from I in the left hand side is what? Peak. You already saw this. The next item in the stack, stack.peak. That is correct, looks correct. That's it. Yeah, that's it. Should we run this on lead code? Should I run it first? Accepted. Submit. If we get error, we will solve it, no problem. Oh, accepted. Very nice. Cool. Good one. Memory wise, it beats 97% of the folks. You know, looks good. Very nice. It's simple. Okay. In the previous videos, I told you how to use debugger and everything. You can use that. It has an inbuilt over here. You can see debugger over here as well. You can directly integrate with your Git, do all sorts of things. That's good. Good question. Right. Let's move forward with the next one. Before moving forward to the next one, yeah, this was asked in Google. So, very simple stuff. This one is time complexity of this getMax function is what? Constant. No loops, nothing. Constant. And this is linear. This is what? The size of the stack, which at max can be the size of the heights, and this is we are running from height, so height into height, getting some quadratic stuff. So you can figure that out, very simple. Around time complexity, if the interviewer asks you, no problem at all. Extra memory that you're using, yes, you're using linear memory because you're making a stack, and the maximum value of that stack will be the maximum value of the height. So O of n will be space complexity here. Okay, cool. Let's move forward to the next one. All right, next question. Again, easy question, but this question will build on top of other questions asked at Google, Facebook, which is now Meta. Very simple question. It's literally like, it's amusing how easy this is, and that's not the point I'm trying to make. What I'm saying is that there are additional questions that are formed as a structure. So let's take an example. What is this question? You're given a string. You have to determine whether a string is valid or not. Okay, what do you mean by valid string? Valid string means open brackets must be closed by the same type of brackets and in the correct order. So this is open and closed, nullified. Okay, open, closed, open, closed, open, closed. Okay, closed. This is open, but this is closed so it's open as a circle bracket, but closed as a bracket like a square bracket. So that's not nullifying each other, and that's not cool. So yeah, that's what we have to do. So how do we know stack is being used in this? How do we know? Well, obviously we'll start reading so let me actually bring in the whiteboard. Okay, let's bring in the whiteboard. Okay, so let's see this on a whiteboard. If I talk about, let's say we have this thing, and then we have what kind of bracket? Curly bracket and square bracket. Square bracket, curly bracket. So curly bracket will close this, then square bracket, and then like this. So I'm able to cancel this out. If this is cancelled out, then nothing is remaining. Then this is also adjacent to each other. I can cancel this out. This is also adjacent to each other. I can cancel this out. That is fine. But you can't do it something like this. Curly brace, square brace, curly brace, square brace, circle. Because now these two will not cancel each other out. Hence, nothing will cancel each other out. So you have to make sure you cancel each other out. And for that, at a minimum point, there should be someone that cancels each other out, because this here at the minimum point, it is not cancelling each other out. In that case, this will just not work out. How do we do it? So a simple idea is, obviously we have no idea until we traverse what is on the right hand side. Okay, what is on the right hand side? So you start from here. You keep a track of these, and you have to keep a track of this in this order only, because it's not like you found a circle here, then you can just remove a circle when you found another circle. You can't do that. You have to keep a track, and you have to keep a track in order. 100% stack will be used, 100%. Why? Because Kunal said whenever you do some things like in order, and we have to keep a track of like whatever came in the past or whatever, stacks are used. That is why also recursion is used in most problems, because you're taking into consideration what happened in the past and you're storing that in the stack memory. Okay, stacks will be used, very simple. Keep storing it in the stack, that's it. So something like this. If I talk about, let's say, stack, if I talk about this, then I talk about something like this. Multiple ways to do it. You can take a counter if you want. It won't change the time complexity that much. Or you can take 3 counters if you want, or you can do like just put it in the stack as it is. So I put in the stack this one. Then I go over here. I put in the stack curly brace. Then I go over here. I put in the stack square. Then I go over here. Whenever you find a closing bracket, check the top of the stack. Hey, is this closing bracket closing the one at the top of the stack? Yes, it is. Okay, then remove the top of the stack. If it is not doing it, return false. Okay, because the first closing item that you should find should be able to close the topmost closing item on the stack, otherwise there will be a conflict, as I just showed you in the example, in the previous example that we took. That's it. So remove this. Then we have the curly brace closing. Okay, is curly brace closing the topmost item in the stack? Yes, it is. Remove it. Is this closing the topmost item in the stack? Yes, it is. Traversal empty, stack empty, return true. That's it. Simple. That's it. Time complexity, O of n, because you're traversing it only once, which is n is the size of the string or whatever. Space complexity, O of n, because that's the amount of stack you have at maximum point or whatever, right? Be that n by 2 or something. So constants removed or whatever, right? Very simple stuff with stack. I told you the thought process and everything. Okay, let's code this. Okay, so new file, valid parentheses dot java. Solution or whatever, string s we have over here. Create a stack, import java.util.stack, and we're going to have a stack of type character. Stack is equal to new stack. No problem at all, right? What do we need to do? We need to traverse this array. So we can create we can do an array. We can do for char ch in my string dot to char array. Sorry. Char ch. Okay. So here we have the char ch, and now I can check for ch. So I can say that if my ch is equal to I say this, or ch is equal to this, or ch is equal to this. Stack dot push ch. Sounds good, right? Otherwise, if ch is equal to closing, do something. If closing this, right? So here I will check that if stack dot peak is not equal to closing, or if my stack becomes empty, in that case I will just say return false. Opening, that looks good. In the end I will just say return stack should be empty, then it will be okay. Stack empty, then it's true. Is empty. Okay, one more thing we have to do is we actually have to, if we are checking it, we have to remove it also. So instead of peak we will do pop, right? Because we are removing it, right? As we were removing it from the whiteboard, the stack. That looks good. Now we can submit it. Okay, And one more thing you have to keep in mind when you're doing such problems is, so when you're doing this pop, it might be possible that stack becomes empty, but we have to check whether the stack is empty before popping it. So make sure that this is fixed as well. The whole reason we are doing this stack.isEmpty is because we want to make sure that we are not popping from an empty stack, otherwise that will give me a error exception or whatever. Copy this, paste it, run this. That looks good. Submit it. Accepted. And runtime 99% faster. Very cool. Sounds good. We already discussed when we were doing the whiteboard stuff, the space and time complexity. Nice. Very easy. Let's move forward. Okay, next question. That was an easy one. So this is a medium one. And this was asked in Facebook, now Meta. Very simple question. So same thing, but in this case, it's only having, the circle brackets, and it's saying what are the minimum number of insertions you have to make these parentheses valid. Let's see how we can do this. Okay, is this thing any different? Like if you talk about it, so you're saying that you have something like this, this, and this. This is given to you. What are the minimum number of brackets you have to add, be that closing or opening, to make this a valid one? So only one, that is valid now. Okay. Again, we know from the previous explanation only, stack will be used because we're taking answer till, like we have to store the brackets as we are seeing them in order. Okay, and when we get a closing bracket, then we will take it out of the order and remove it. Same thing we'll do. We'll put it inside the, you can take it as whatever you like. If I talk about this example only, this is not a very good example, but if I take a nice example, close, something like this. How many do we need to add in order to make this balanced? Actually, no. Remove this one. How many do I need to add in order to make this balanced? Let's see. I put this C over here, this bracket. Then I put another one over here. It was first here, then I'm here. Now I'm over here. Do we have a closed bracket right before this? Yes, we do. Okay, remove it. Now we're over here. Do we have, now we're over here, so we just put this here. Now we're at the end. So we need to add two brackets, one for this, one for this. These two will be at the end when you're done traversing, whatever is the size of left. So the size left basically means the parentheses that do not have a closing or an opening bracket. So size is what? 2, because this was removed. So 2 is the answer. That's it. Want to code it? Pause it, try it out yourself, but we can code it as well. Not a problem. Okay. Valid parenthesis. I'll create another file, valid paren minimum add.java. Facebook question. So it is very simple. Is this really medium question? I don't think so. That is why, see, this is what I'm trying to tell you. Many other courses will tell you like, oh, in this video we'll teach you how to clear, FANG interviews, and we'll teach you how to clear all the coding rounds, and you'll get into FANG, and it's very hard work, and so many other things. No. This is why I don't follow influencers that much. Very little people are honest, in this world, because they have to sell themselves. Like, oh, you want to clear FANG interviews? Buy our courses. That is the only way to clear FANG interviews. No. In reality, the answer is FANG interviews are very easy. Via this video, via this boot camp, I want it to be a one-stop solution for someone who has never done coding in their life to be able to clear FANG type interviews. And that is your second priority. My main motivation for people is to get into open source. Look beyond FANG, especially for people in India, because FANG in India is a very funny thing. They don't offer much, pay is below average. It's nothing. That, these are not my opinions. These are facts. I'm not the one who is paying, $15,000 per annum. Microsoft is doing that in India. $15,000 per annum. In remote work, that's like pocket change. So, again, these are not opinions. These are facts. So, via this bootcamp, definitely you will be able to clear interviews. But via this bootcamp, I'm also promoting how easy clearing these interviews are, and you should not take it seriously. Do not take FANG seriously. FANG coding interviews are all textbook. Coding interviews, that is why are not very, good assessment. These are very textbook. Few lead code questions, you'll be able to clear it. There isn't much you can do in 45 minutes. Some people have multiple rounds or whatever. But at least if you're just starting out or whatever, yeah, lead code more than enough. More than enough. So via this bootcamp, I'm not saying clear FANG interview, get into FANG. No, I'm saying clearing FANG interview is a very easy. Marking my words. It's very easy. Watch this video, watch these bootcamp, do the assignments, all the links and codes description in the description below. Do all the assignments and everything. Be FANG interview ready. Spend the rest of your time doing open source and remote work. FANG, keep it as your backup option. Worst case scenario, you will go for FANG. If you don't get a job anywhere else. Worst case scenario. That is what I'm promoting via this bootcamp. And it's all in front of you. Is this a medium question? This is not a medium question. Check out my linked list video. What a joke linked list is. I'll do trees next after this. You'll see what a joke tree is. It's like joke, literally a joke. Okay. So let's code this. And I have to create a stack of, again, character. Stack is equal to new stack. Right? For just copy this. For this thing, for every character, if ch is equal to, let's say, closing bracket, then I will check. If not stack dot is empty, and I'll check stack dot peak should be equal to, let's say, closing. In that case, we're not going to do anything. We just remove item from the stack. That's it. Otherwise, I will just add item in the stack. Stack.push ch. Right? On the other hand, if this is not equal to closing bracket, if it is equal to opening bracket, then also I will put it in the stack. In the end, the answer is going to be equal to stack.length, or what is it? Size. Run. See how that goes. Accepted. Submit. Accepted. Good one. All right. So that's good. You can also check out like the next question, more challenges. Let's check out another question. Minimum insertions to balance a parenthesis string. It's another nice question that we can take a look at. This one is also medium. It's also very simple, and the thumbs up are also not that much. So I don't like this ratio that much. It's all right, not that worth it. But it's similar to the previous one. In this case, One opening bracket means two closing brackets. That's it. One opening bracket means two closing brackets. So that's what you need to do. Exactly as previously, but you have to just put some little conditions. That's it. In how you're adding stuff. Okay. Some hint I can give you. This you try it out yourself. It's nothing much. You just take, let's say, two variables, open and closed. So you just make some conditions, right? Okay, if you find a bracket that is, let's say, closed, then okay, then check if the next bracket is also closed. If the next bracket is also closed, then you just see peek from the stack. If you peek from the stack and see that okay, we have found an opening bracket, then you can cancel it out. Otherwise, you can just increase the counter of how many are open, how many are closed. In the end, you can just return some sum or something formula like that. That's it. It's exactly like similar like last time, just some additional conditions, because two closing brackets are closing, one opening bracket now. So I think you can try that out yourself. I'm not going to solve this one because it's actually a good practice for you. First of all, you will have a good understanding because we already did a very like good level question, which was largest area histogram also. We already did two of valid parentheses. So nothing new concept is not available over here. Concept is that only. Stack, peek, pop, multiply. That's it. Just the condition is changing. So that is why you try it out yourself. And that's basically about it. Thanks a lot for watching. I'm really excited to complete this playlist. We'll do trees next. So if you show good enthusiasm, I want everyone to like this video. I want everyone to comment on this video. I want everyone to share this video on socials. These are three things I want you to do. The more you do it, the more it will help me gain the enthusiasm to continue with the DSA playlist. I don't need your money or anything. I'm doing this for free. And I want every single student in this world to realize how easy it is to clear coding interviews without paying a single penny, right? So three things you have to do. You can take a screenshot and hashtag DSA with Kunal. You can join that. So if you go to twitter.com and you go to hashtag DSA with Kunal. Oh, there's a Twitter account. Interesting. Bring back DSA with Kunal. Anyway, appreciate the support. So as you can see, started with DSA with Kunal. See, people are learning. How many tweets are there? I have no idea. Tens of thousands or 20,000 tweets. DSA with Kunal was also trending on Twitter at one point. And in the link in the description, you will also find GitHub repository for the questions and assignments that you can do to better improve your, practice and stuff, because self-study is very important. So make sure to check out the links in the description below and share, comment, like, share it everywhere. And when I launch the trees video next, it will just blow your mind. Trust me, because I will prove to you why trees is a joke. Such hard level tree questions we will do like this, and we will do it using just two formulas. I will teach you two formulas. We will solve 30-40 questions with that. All the popular tree questions, invert a binary tree, adjacent addition of the nodes, diameter, height, and BFS, DFS, topological sort, whatever. It's all a joke. Okay, these are nothing. It's like below very easy questions. Okay, so we'll prove that in the next video. I'm getting very excited. So I want to see you get excited as well. Thanks a lot for watching. If you are new to the playlist, check out the playlist in the past, and I'll see you in all the videos we've done in the past, and it's all in the description below. Just check the description once. It will solve all your problems. And I'll see you in the next one. Have a great day. Make sure you do the action items that I mentioned.